Chapter 6, questions 3 and 4 say, state the number of electrons lost or gained when the following elements form ions. Now these questions are building on exercises 1 and 2 in Chapter 6, so to understand the fundamental concepts behind these, I encourage you to watch the videos for those two exercises if you haven't already. So for this video, I just want to show how the method that we established in those previous two questions can be applied to these specific elements. So for the first step in each of these is to draw the Lewis dot structure. So that's a structure where the symbol represents the nucleus and all the inner electrons, and the outer electrons are drawn as dots around the symbol, as if the symbol had 4 different sides. So let's start with strontium. Now, strontium is a metal in group 2A. So here, to draw the symbol, you can write the SR, and then you would want to note that because strontium is in 2A, it has 2 valence electrons. You can imagine this strontium as having sort of 4 different sides, and you would want to put one electron on each side before you start pairing them up. So, for example, 1, and it doesn't matter which side you start on. I tend to start on the right, but starting on any side would be correct. So that's 1 electron, 1 valence electron, and then 2 valence electrons. And because strontium is in group 2A, that's all of the valence electrons on strontium. And this, without those lines there that I just put in for guidance, that would be the Lewis dot structure for strontium. Now, an atom is unstable. Each electron is like a little magnet that's unstable unless it's paired up. So the goal, these atoms are going to react until they have no unpaired electrons. They could either gain electrons so that all their electrons are paired, or they could lose the unpaired electrons so they at least don't have any unpaired electrons. So let's think about both of those cases. If this element were to gain electrons, you'd have to put the next electron on the left and the next electron on the top, because you have to have 1 electron on each side before you start pairing them. Then, to get all of these electrons paired, you would have to add 4 more electrons. So that total, we would have added 2, 4, 6 electrons. There are 6 green dots. Those are 6 electrons that we added. So strontium can get all of its electrons paired, either by gaining 6 electrons or just by losing the 2 that it started with. And so it's easier to lose those 2 electrons, and so that's what strontium does. So strontium loses 2 electrons. Okay, now let's think about phosphorus. So phosphorus is sort of on the right top of the periodic table. If we wanted to draw the Lewis structure, you would write the capital P, that's representing the nucleus and all of the inner electrons. Because phosphorus is in group 5A, it has 5 valence electrons. So we can draw those in, put 1 on each side before we start pairing them. So there's 4, and then the 5th one we can pair. So phosphorus has 3 unpaired electrons. And so, for it to get all of its electrons paired, it can either gain 1, 2, 3, so the green ones are the ones it can gain, or it could lose the original 5 that it had, the orange dots around the phosphorus. It's easier to gain 3 electrons than to lose 5, and so phosphorus gains 3 electrons. C is an interesting case because it doesn't give you an element in particular, it just says you're in group 7A. So I'm going to put just an X here because we don't know what the element is, so like an X in math. But what we do know is that whatever the element is, it's in group 7A. That's what they're giving us. And that means that this element, whatever it is, has 7 valence electrons. So we'll put 1 on each side before we start pairing them, so that's 4. Now we can start pairing them, so 5, 6, 7. So this only has 1 unpaired electron. It can get all of its electrons paired either by gaining 1, the green one, or by losing the 7 orange ones. It's easier to gain 1 electron than to lose 7. So here, this element, anything in group A, would gain 1 electron. Okay, how about sodium, Na? Na is at the top left of the periodic table. If we wanted to draw the Lewis dot structure, we could draw that capital M, lowercase a. That represents the nucleus and all of the inner electrons. Because sodium is in group 1a, it's going to have 1 valence electron, so we can just write that next to it. Now, for sodium to have all its electrons paired, it can either gain 1, 2, 3, 4, 5, 6, 7, the green ones, or it can lose the 1 that it had. It's easier to lose the 1 than to gain 7, and so sodium loses 1 electron. Let me write this so it's more clearly a 1. There we go. All right, how about bromine? Well, bromine is on the sort of middle right of the periodic table. Well, it's on the right side, but in the sort of middle, not top or bottom. And so if we wanted to draw the symbol for that, the Lewis dot structure for that, we draw that Br. That's representing the nucleus and all the inner electrons. And then, because bromine is in group 7a, it's going to have 7 valence electrons. So I'll put 1 on each side before I start pairing them, so that's 4. Now I can start pairing them, 5, 6, 7. Notice bromine only has 1 unpaired electron, so it can get all of its electrons paired, either by gaining 1, the green dot around the bromine, or by losing 7. It's easier to gain 1 electron than to lose 7. And so you always go with the smaller number. And so bromine gains 1 electron. Question 4 in chapter 6 is the same thing, just with different elements. So we'll go through that same procedure. So first, with oxygen. Oxygen's in the top right. If we wanted to draw the Lewis dot structure, we'd have that O there, and that's representing the nucleus and all the inner electrons. Because oxygen is in group 6a, it's going to have 6 valence electrons. We'll put 1 on each side before we start pairing them. So that's 4. Now we can start pairing them, 5 and 6. Oxygen has 2 unpaired electrons. To pair them up, it could either gain 2, the green dots, or it could lose 6, the orange dots. Always go with the smaller number. So oxygen would gain 2 electrons. 2 is smaller than 6. Okay, how about group 2a? That's a sort of vague description, but group 2a is anything in this column. Notice that everything in that column is going to have the same sort of behavior in terms of how many electrons it either needs to lose or gain. So they don't tell us what the element is here, and so in drawing the Lewis dot structure, I'm just going to draw a big X, because we don't know what it is, so it's like an X in math. Because this element is, whatever it is in 2a, it has 2 valence electrons. And you have to put 1 electron on each side before you start pairing them. So to get all of its electrons paired, it could either gain 1, 2, 3, 4, 5, 6, all the green dots, or it could lose 2, the orange dots. So always go with a smaller number. 2 is smaller than 6, and so this element would lose 2 electrons. Okay, how about fluorine? Fluorine is in the top right of the periodic table. So to draw its symbol, you'd write that capital F, and that's representing the nucleus and all of the inner electrons. To draw the valence electrons, the outermost electrons, look at the group number. It's 7a, so that means fluorine has 7 valence electrons. Put 1 on each side. Each of these dots represents a valence electron, 1 on each side before you start pairing them. So now it's 4, now 5, 6, and 7. Fluorine only has 1 unpaired electron. So to get all its electrons paired, it could either gain 1, the green dot, or lose 7, the orange dots. Always go with the lower number, and so fluorine will gain 1 electron, the green one in that Lewis dot symbol. Okay, potassium. That is K, the capital K. Potassium is on the left side of the periodic table. So if I wanted to draw the Lewis dot structure for it, I could draw this symbol, capital K, and that's representing the nucleus with all its protons and neutrons, and also all of the inner electrons. then we just have to write in the outer electrons, the valence electrons. Because potassium is in group 1A, it just has one valence electron. So to get all its electrons paired, you could either add 1, 2, 3, 4, 5, 6, 7, the green dots, or it could lose 1, the orange dots. And so you always go with the lower number. Potassium loses 1 electron. All right, last but not least, rubidium, Rb. Rubidium is on the left side of the periodic table. If we wanted to draw its Lewis dot structure, we could write that Rb. That represents the nucleus and all of the inner electrons. Because it's in group 1A, we know that there's going to be one outer, or valence electron. And so that is the Lewis dot structure for rubidium. And you could see that rubidium, either to get all of its electrons paired, either could gain 1, 2, 3, 4, 5, 6, 7 electrons, the green ones, or it could lose the 1 electron. Always go with the lower number. So rubidium would lose 1 electron. And so you could see how the electrons are either going to fly to atoms or away from them in order to get all of their electrons paired. And these electrons are sort of going to act like the glue that sticks our Legos together. And so how they move will determine the reactions that we're going to see.